come on in. It's raining again, so please close the door behind you. This particular story has been waiting a long time to be properly read. I'm Mith, and this is the History Sanctuary. Please, come sit with me by the fire. Let me pour you a drink. Whether you're settling in to learn something new, filling in the background while you work or study, or simply letting the past carry you gently off to sleep, you are exactly where you need to be. Tonight, we will be going back about 2 million years to an ancient lake where things may have gotten a little crowded for our ancestors because several different ancient hominin species were living there, all at the same time. This is a place where history is told quietly, carefully, the way it deserves to be told, not as a list of dates to memorize, but as the story of real people in real places doing remarkable things that most of the world has long since forgotten. Everything you hear in the sanctuary comes from real research, real discoveries, real scholars, and this is a real voice. I'm not generated nor synthetic. Just me sitting in my little library, turning pages by the firelight and sharing what I find. If you're planning to drift off to sleep tonight, please do me a favor and like, follow, and leave a comment before you close your eyes. The algorithm won't wake you up to remind you, and is rarely kind. But I'd love to have you back again. For everyone else, welcome to the archive. The kettle's on, the rain isn't stopping anytime soon, and we have so much to talk about. 2 million years ago, on the eastern shore of a great lake in what is now northern Kenya, something was happening that we are only beginning to understand. The lake was enormous. Ancient Lake Turkana, in its earliest incarnation, a vast inland sea cutting through a landscape of open woodland, grassland, and volcanic ridges. Crocodiles the size of cars patrolled its shallows. Sabertoothed cats moved through the grass at the edge of the tree line. Hyenas the size of today's lions picked through the kills left behind. And walking through all of it, foraging, watching, surviving, were not one, not two, but 4 distinct kinds of human relatives. Not ancestors and descendants of one another, not one species evolving into another in a neat sequence. 4 kinds, alive at the same time, in the same place, navigating the same world. We once thought human evolution was a ladder, a single line climbing upward from some kind of ape to us, each rung replacing the one before. The shores of Lake Turkana tell us otherwise. Tonight, we open the files on 4 of the most fascinating beings who ever lived, and on one of the strangest scientific arguments in the history of paleoanthropology. The Turkana Basin sits in the Great Rift Valley, the vast geological tear in the Earth's crust that runs from the Middle East down through East Africa, the crack in the world where tectonic plates are slowly pulling apart. It is one of the most fertile grounds for ancient bones on the planet, because the same geological forces that pulled the land open also buried and preserved what lived there across millions of years. 2 million years ago, this was a landscape of extraordinary ecological richness. Wetlands and forests crowded the lake's edge. Broader grasslands stretched beyond. Rivers wound between them. It was not much unlike the Serengeti today, alive with everything, teeming with teeth and feathers and hooves. The 1975 discovery of 2 specimens from the same stratigraphic layer, a Paranthropus boise skull and a Homo erectus skull found together, was the first direct evidence that more than one species of early human lived in the same geographic area at the same time. It cleared up a long-standing controversy and confirmed what some had long suspected. That discovery cracked the ladder open. What emerged in its place was something more like a bush, branching, tangled, and far more interesting. This story is old and somewhat worn around the edges because scientists have been arguing about it for about 60 years. Homo habilis, the handyman human, named in 1964 by Lewis and Mary Leakey, based on bones found in Tanzania. This species, along with its controversial cousin Homo rudolfensis, is one of the earliest members of the genus Homo. Its naming required a redefining of the genus itself, specifically lowering the minimum brain size required for membership, which sparked an enormous debate about whether this species legitimately belongs to Homo at all. That debate has never fully ended. But here is what the bones tell us. Homo habilis was small. Females stood perhaps 3.5 feet tall, barely reaching your shoulder. Males a little taller, perhaps 4.5 feet. Body proportions were similar to those of the earlier Australopithecine ancestors. Long arms, short legs, a body plan built more for climbing than striding. Their brain, by modern standards, was modest, averaging around 600 cubic centimeters, with yours being roughly 13 to 1400. But compared to the Australopithecines that came before, it was meaningfully larger. Something was changing. Something was growing. Their faces were flatter than their predecessors. Their teeth were smaller. Their hands, and this is the important part, were capable of making things. The Oldowan stone tools, simple flakes of rock knocked from a core, sharp enough to scrape flesh from bone, sharp enough to crack open marrow-filled legs, and access a calorie source no other animal was exploiting. It is thought that Homo habilis derived meat primarily from scavenging, acting as a confrontational scavenger, stealing kills from smaller predators such as jackals or cheetahs. Fruit was likely also an important dietary component. Picture them small, wiry, moving in groups along the lake's edge, watching the sky for vultures circling a fresh kill. When a predator moves off, they rush in, loud, threatening, dangerous enough in a group, and get to work with their stone flakes before the lions come back. Every calorie counts. Every marrow bone cracked open is the difference between making it tomorrow or not. They were clever. They were small. And crucially, they were not alone. In 1972, Richard Leakey's team found a skull on the eastern shore of Lake Turkana. It was a mess, crushed and scattered, more than 300 fragments lying in the sediment. The team collected every piece they could find, and they were taken back to Nairobi, where a skilled preparator named Mith, later Mith Leakey, spent months reconstructing it. When it was done, the skull had a catalog number, KNM-ER 1470, and it did not fit. While the skull was about 1.9 million years old, the same age as many Homo habilis specimens, KNM-ER 1470 had a brain size of around 775 cubic centimeters, considerably above the upper end of Homo habilis brain size. It also had a longer face and larger molars and premolar teeth. The face was wide, flat, almost architectural, a broad platform of bone projecting forward in a way quite unlike the smaller skulls being assigned to habilis. The tooth sockets were large, implying massive back teeth. The brow ridge was slight, almost delicate. Homo habilis? Or something else? The explanation proposed at first was that 1470 was simply a male, and that the other two very different skulls represented a gender dimorphism within the same species. The male was bigger, with a bigger brain and a bigger face, and the female smaller. But the anatomy of the two skulls differs considerably, not just in size, but in shape. The upper jaw of 1470 was square, the other was rounded. The brow ridge of 1470 was slight, the others were strongly developed and pronounced. In 1986, British paleoanthropologist Bernard Wood proposed that 1470 represented an entirely different species. He gave it a new name, Homo rudolfensis, after Lake Rudolph, the colonial name for Lake Turkana. The argument began. Here is the honest state of this file. It's contested, more so than almost any other species in the human family tree. There is only one really convincingly complete fossil definitively assigned to Homo rudolfensis, the reconstructed skull of 1470. No bodily remains, no arm bones, no leg bones, no hands or feet are definitively assigned to this species. Consequently, both its generic classification and its very validity as a species are debated, with some recommending it actually belongs in Australopithecus, or that it is simply the same species as Homo habilis. And yet, the differences are real, where Homo habilis had a brain around 500 to 600 cubic centimeters, Homo rudolfensis had a brain closer to 750 to 775 cubic centimeters, while habilis had relatively small, refined teeth. Rudolfensis had large, broad molars, more reminiscent of the Australopithecines. Where habilis had a pronounced brow ridge, Rudolfensis had a flatter, wider face with a slighter brow. Think of two people you might pass on the street who look quite different. Different bone structure, different jaw, different scale. And the question of whether they are the same species or a different one becomes surprisingly hard to answer from bones alone. The debate essentially comes down to this. The fossils first classified as Homo habilis were quite variable. As more were discovered, some had larger cranial capacity and strikingly different face shape. Some scientists proposed splitting them into at least two groups. Others argued that the variation was simply the natural range within a single gender dimorphic species. Some researchers have gone even further, suggesting that all earlier African Homo habilis, rudolfensis, and even early erectus are so similar to specimens found in Georgia that they could be considered a single, highly variable species, Homo erectus. This view, sometimes called minimalist position, has not been widely adopted, but has some serious support. The most honest answer in 2026 is this: we do not know. The question of whether Homo rudolfensis and Homo habilis are indeed different species, or part of the same single variable species, or one the ancestor of the other, remains one of the genuinely unanswered questions in paleoanthropology. What we do know is that in the Turkana Basin, around 1.9 to 1.8 million years ago, there were beings with notably different skull shapes and brain sizes living in the same landscape. Whether we call them one species or two depends on how much variation we think a single species can contain. Nature, as it turns out, is not obligated to make this easy on us. As for the next set of feet that walked along that shore, Homo erectus was different in kind from the others. Taller, close to 5.5 feet in some populations, longer-legged, built for distance, a brain volume that grew over its long history from about 600 cc to nearly 1100, bridging the gap between early and modern humans. The species appeared about 1.8 to 2 million years ago and spread throughout Africa and Eurasia in several migrations, surviving for more than 1 million years, longer than any other species in our genus. They carried more sophisticated tools. They may have controlled fire. They were the first human beings to leave Africa and populate the wider world, reaching Georgia, China, Southeast Asia, and eventually the island of Java. What was long assumed that habilis evolved into erectus in sequence was challenged by discoveries in 2000 of a relatively late 1.44 million year old Homo habilis specimen and a relatively early 1.55 million year old Homo erectus from the same area of northern Kenya. These coexisted in East Africa for perhaps 500,000 years. Homo habilis was not simply replaced by Homo erectus. They overlapped. They shared the same landscape, the same lake, the same morning light. What that meant for their interactions, competition, avoidance, perhaps occasional exchange, we can only imagine. I would be remiss to leave out, and will mention here, that there is a taxonomy controversy about Homo erectus around this time period as well, of course. Some scientists consider certain older African Homo erectus specimens to be a separate species from Homo erectus that left Africa to branch out into Eurasia, called Homo agaster. A famous partial skeleton called Turkana Boy was found at this same Lake Turkana shores in 1984. For example, he has been called Homo agaster by some, and we can certainly get more deeply into that story on a future evening, and why there is a controversy over whether or not agaster needs its own name. After all, Homo erectus absolutely deserves stories all its own. And then there is one who does not belong to our family at all. Well, not really, but yet it was there. Paranthropus boise, the robust one, the nutcracker man. They weren't our ancestors, but they grew and lived and survived beside them. The well-preserved skull was first discovered by Mary Leakey in 1959 in Tanzania and dated to 1.75 million years old. It had characteristics so distinct that Louis Leakey initially gave it its own genus entirely. If you were to look at the face of a Paranthropus boise, and you see something that stops you cold, a massive dished face, wide cheekbones flaring outward like wings, creating a broad platform of bone, a brow ridge, thick and heavy, and the teeth. Flaring cheekbones gave Boise a very wide and dish-shaped face, creating a larger opening for bigger jaw muscles to pass through and support massive cheek teeth, 4 times the size of a modern human's. This species had the thickest dental enamel of any known hominin. The skull of a male boise often bears a sagittal crest, a ridge of bone running along the top of the skull, like a raised seam. This was not for decoration. It was an anchor point for the enormous muscles that powered the jaw. Males were built like chewing machines. And yet, not quite nutcrackers despite the name. The micro-wearing patterns on the molars, when studied closely, turned out to be inconsistent with a diet of hard foods. Instead, they more closely resembled the wear patterns of the fruit-eating primates. The most likely interpretation is that Boise could crack hard fallback foods when necessary, but primarily ate softer vegetation, grass seeds, tubers, roots, and fruit. New fossils discovered between 2019 and 2021 and published in 2025 gave us, for the first time, a picture of the whole body. The fingers of Boise were, in many respects, more like a gorilla's than a human's. Broad, powerful, built for grip. But the feet were remarkably human. Arched, rigid, with the same upward joint tilt that allows us to push off powerfully when walking. Boise was an efficient biped, walking on the feet that resembled ours more closely than those of the earlier species. Picture them moving through the lakeshore woodland, stocky, thick-necked, unhurried. Their gait perhaps slightly heavier than the Homo species nearby, their jaw muscles bulging at the sides of their wide skulls. Not frantic scavengers, not long-distance walkers like erectus. Something more settled, more patient, pulling roots from the earth, grinding seeds between those enormous molars, spending long hours eating what the others passed by. Paranthropus wasn't a failed hominin relative. It was a successful species in its own right, perfectly adapted to its ecological niche for well over 1 million years. For context, our own species, Homo sapiens, has existed for roughly 350,000 years. Boise lasted for well over 1 million. By any measure, that is success. And then the climate changed. Scientists have one prevailing hypothesis for the extinction of Boise. It was unable to adapt to a rapidly changing environment. When the Earth's climate became intensely irregular, with fluctuating hot and cold spells, food resources shifted. Certain plants dwindled or died out. A species that had specialized in processing a particular range of foods found itself with a body built for a menu that was disappearing. Homo, with its flexible brain and its tools and its willingness to eat, well, let's face it, almost anything, adapted. Paranthropus, magnificent and enduring, did not. Sit with this a moment. 2 million years ago, on the eastern shore of Lake Turkana, you could theoretically have seen on the same afternoon 4 distinct kinds of beings walking upright across the same landscape. A small, clever scavenger with stone tools and a modest brain, picking its way through the scrub. A larger-faced, bigger-brained cousin, who may or may not have been a completely different species, depending on who you ask and how you read the bones. A tall, long-legged walker who was already beginning the journey that would eventually carry our lineage to every corner of the earth. And a wide-faced, powerful, deep-chewing specialist who would outlast 3 of the others and still, in the end, lose. More than 1 million years ago, on a hot savanna near the shore of what would become Lake Turkana, 2 completely different species of hominins may have passed each other in the same habitat, occupying different ecological niches in the same landscape. They were not competing for identical resources, so they were not necessarily in conflict. They may have regarded each other the way the different animals in a mixed species herd regard one another, aware, cautious, occasionally in contest over food or water, but largely inhabiting different enough niches to coexist. The question that haunts every researcher who works in this landscape is one we cannot answer. Did they see each other? Did they watch each other from across a clearing? Did the small, tool-carrying habilis look at the massive jaw of Boise and feel something we might recognize as recognition? That strange sense of facing something related but different? Did Erectus, taller and more modern-looking, regard the smaller species with something like understanding? Did they live in harmony, or was it a constant, clear, and present danger, leading to why humans today sometimes get that uncanny valley feeling? We cannot know. But it is nice to think of that shore as just a little bit crowded. Or we can say this: evolution was not a march. It was a conversation. A messy, branching, overlapping conversation. Multiple experiments running simultaneously. Different answers to the same question: how do you survive in a world that is always changing? Brain and flexibility won in the end, but it was not inevitable. And for a long time, a very long time, it was not clear who would prevail. The Smithsonian website notes, almost in passing, 4 species in one basin between 2 and 1.5 million years ago. But that sentence contains multitudes. 4 species, 4 ways of being human or nearly human, 4 sets of eyes watching the same lake, the same sky, the same predators moving through the grass. 4 answers to the same impossible problem. We are what remained when the others were gone. But they were not failures. They were experiments. Some ran longer than we have. Some carried in them possibilities we will never fully know. We covered the Tong child last time, a story about science losing its collective mind because of a little brain. If you missed it, it's here waiting for you, along with some great music here on the sanctuary for relaxing as well. Now, if you enjoyed relaxing by the fire with me tonight, please subscribe, like, and let me know what other ancient stories you would like to hear. We have a lot of history still to unpack. And of course, the kettle is always on.